So all I was saying just now, everything that I'm teaching you, everything you can read and you can watch in the internet. So nothing new. So in the class, we are supposed to ask me question that which you don't understand. That's the reason for class, right? So in terms of information, you can get the information in the internet. But maybe sometimes you don't understand. This is why the class is important for you to ask questions. Okay. Uh, yeah, I want to full screen. Can you see my full screen?
Yes.
Diffusion. Okay, next is, then we talk about two main mechanism or current mechanism inside a semiconductor. One is diffusion, the second one is drift. So what's the main difference between drift and diffusion current?
The diffusion is due to the carrier concentration, while
Drift
the
is
drift,
electric field.
Yes. So diffusion is due to the difference in carrier concentration and drift is due to electric field. That's very important. So, okay, so interesting, all popping up. I don't know why my screen. Okay, so what do you call it? You can find the relationship, the equation to relate between the mobility and also the what do you call this? This is the velocity. Okay, and also the current equation. So you have a equation, the current equation, this is current density. J is current density. J is current density is the current divided by the area, not the volume. Although we call it density, but it's divided by the area of the semiconductor. Then this is the equation. So you have drift and diffusion and drift current due to electron hole. So you have two current. In semiconductor, you have two current, which is current due to the electron and current due to holes. Sometimes if the doping is n-type, the current due to hole is negligible. It's very small. Okay. So you can find the equation here. I won't go through it again. So you need to know what's the difference between conductivity and resistivity. And here's the equation of the diffusion current. Dn is the electron diffusion coefficient. So this normally will given to you. So different material will have a different Dn. And Dn over dx is the difference in carrier concentration. The higher the difference, you have two material, right? You have two material, and with the bigger the difference in carrier concentration, the more current will flow. For example, this 50, this is 10. So compared to 50 and 40, if 50 and 40, the diffusion current is less. 50 and 10, the difference is bigger, so you have more current. Okay, that's on diffusion. So, mana drift ni? Oh, tadi drift ke? Oh, tadi drift. Oh, this is due to drift. So this drift and is the main component is the electric field. The higher the electric field, the more drift current you have. Okay. PN junction. So PN junction, who wants to tell me? How do you get a PN junction? How does it, what happens when you combine P and N material together?
there is several stages. The first one is diffusion.
Okay.
And then recombination happen, and then depletion.
So explain what kind of diffusion happens. Yes, you can. Tamana. I cannot hear you.
Side will have more holes and the N side will have more electrons. There will be concentration gradient and that is why diffusion will happen.
Okay, so what
Which
do
one?
you do where?
The P side has more holes and they will diffuse towards the N side. N side has more electrons and they diffuse towards the P side.
Okay, good. Next, what happened?
This is the first step. The second is recombination. Recombinations will happen mostly near the junction.
What is recombination?
Recombination is when holes are going from P to N and electrons are going from N to P. These holes can get combined with the electron there and recombine with the electron in the N side and become immobile. The space will become it will
What is
have no free
recombination? What is recombination?
recombination is when this hole will get combined with the electron.
Free electrons with free holes.
So, yes, Iman?
Recombination is the free electrons recombining with the free holes.
Why does it recombine? It's a good question. Everyone can answer?
To achieve equilibrium.
Explain more.
When there is the difference between the positive charge and negative charge, recombination happen to neutralize them both.
Why? Okay, because, okay, let me draw a bit. I need to stop this. Share my iPad. Slow down. Okay. Okay. So my question is now. What was my question?
Why recombination?
Why does recombination occur?
So you have the what do you call it? Conduction band and valence band, right? So the electron will be here, free electrons, right? So this energy, the y-axis is energy. So actually when electrons are free here, when electrons are free here in this area, the electrons are at higher energy compared to the one at the in the valence band. So you know, it's a what do you call it? It's a state. Interesting, a state of fitrah. We all material doesn't want to stay at a high energy. You always want to stay at the lowest energy. You as well, right? Compared to running and sleeping, which one do you like? Right? With high energy and jumping here and there and sleeping. So we human, we also like to sit at the lowest energy. Try to be lazy, not to do anything, right? So, but the same with the electron holes. So electrons, because it's staying there, it has a higher energy. So what happens is it always want to go back to the lower energy. Yeah, right? You will try. How to do that? They can only do that if they found a hole here, right? a free hole. So the electron can recombine here with the free hole, and then what happens? You no longer have the free carriers. So you also lose the free hole, and it becomes in the state of equilibrium, state of is the normal state. Okay, so that's why electron always want to go to down, but you will need to, before it can go down, you need to see free holes first. If you can see, it can recombine. If you don't see, they cannot recombine. It will keep on staying there and move here, there, but it cannot recombine. Okay, then next is recombination, right? So you have first diffusion, recombination, and what is left in the when recombination happen? What is left in the near the junction? Hmm?
The immobile charge carriers, depletion region.
Yes. What is depletion region?
It has no charge carriers, free carriers. It has immobile charge carriers.
Right. So what happens is when you recombine, as I mentioned just now, you are losing free carriers. When you have no free carriers, the place will have no free carriers. But because of the recombination, you also making ionized atom, right? Because it's losing free carriers. At the junction, you are losing free carriers, and it left with atom which is losing its, previously it's neutral, because when it lose now it becomes charged. So on the p side, what's the charge?
Negative.
So why is it become negative?
Because electrons have
It becomes negative because you are losing hole, right? When you let
hole.
it's neutral, you lose the hole, it becomes negative. At the end side, it's neutral, you're losing the electron, become positive.
Positive.
Okay, that's, and do not memorize. If you memorize, you get confused. Try to understand. So then you have recombination over here. So you're left with the ionized atom either side. And this is called the depletion region or space charge region. It's the same thing. Then what happened next? See here, figure left. And what happens after that?
Now there will be a barrier, and we have to give some voltage to overcome this barrier.
Okay, what happens after that is you are creating electric field. Okay, due to the ionized atom, you have electric field. It's like a battery now. So a battery have voltage. What's the relationship between voltage and electric field? Do you remember?
Is equal to voltage.
Relationship, the higher the voltage, the higher the current.
No, relation between electric field and voltage,
Yes,
not current.
electric field and ma'am, between voltage and electric field,
Yes.
V is equal to mu E, related by mobility.
Not in terms of mobility, in terms of distance.
In terms
V is
of
not voltage. V equals to mu E. V is velocity there. You need to be careful.
Oh yeah, velocity, yes.
I want in terms of voltage.
Yeah, electric field is equal to voltage by distance.
Good. So E, electric field, equals the voltage of a distance. So whenever you have any voltage and you have a distance, you have electric field. So the same goes here. So you have an ionized atom, which like a battery, you have an induced voltage. When you have a voltage, then you have a distance, you have electric field. So what happens then when you have electric field?
Current move.
What move?
Carriers will flow.
Huh?
Because the holes will flow in direction of electric field, positive to in.
So what happens is previously we have diffusion current, right? Because of difference. Now due to the electric field, now we have drift current, and the direction of the carriers due to the drift is the opposite of the diffusion. It will follow the direction of electric field. So it's very beautiful how Allah makes it, in the end it's cancel out each other. So beautiful. You know, as a human being, we'll never be able to think about this, but as we human, we just what do you call it, experiment and trying to find out what's happening. So scientists have done this. They say, oh, interesting. What happens is you have electric field, then you have drift current, and the drift current is as the same and opposite direction, the same magnitude but opposite direction of the diffusion. So what happens is a piece of PN junction, you go and get a diode, you will not get electric shock because although they are current, but they are cancelling each other inside here. So it will not come out. So that's his PN junction. That's how you get the PN junction and how it works after that. Okay, so this is the equation for built-in voltage. You learned this during your first year degree. I won't go through that. The maths also you done in your degree. Reverse bias. So then, okay, then we learn about reverse and forward. How many minutes we have left? So what time is it now?
1:07.
To finish?
17 minutes.
1, right? No, 11:30. What time we were supposed to finish?
1.
1.
1?
12:50 actually.
Huh?
But we had 1 p.m. with the break.
Okay. Right. So I'll go very fast and next week next class we can do the new lesson. So this is the reverse bias. You can go and read about the reverse bias. And this is very important in order to explain the photodetector, reverse bias. You need to really know how it works, the reverse bias, otherwise you cannot explain the photodetector. And then forward bias, you need to know how it works, what happens to the energy band diagram. Remember, I asked you to explain in terms of energy band diagram, okay? So you need to, in your presentation, make sure you explain the device based on the energy band diagram. So for photo detector, you reverse bias. For laser and LED, you forward bias. Okay, solar is in between. The light is changing the bias. Okay, so and there's a lot of videos. If you want to make video, also fine, but you have to make the videos. You cannot take videos of other people. Okay, so that's called plagiarism. So, but make sure you understand what's happening because I will ask you a question. Then you have forward bias. Then you have this you learn in your degree, the diode current goes to saturation current. Is basically just the reverse bias current, and it's a function exponential of the diode voltage. Finish. Okay, good. So I think Alhamdulillah, we managed to go through how many weeks of, I call it, of lesson in one class. So next Wednesday, what time we have? 2,